A majestic, cold, serene, blue-green sphere. That's how astronomers saw Uranus when Voyager 2 sent its data. Only a few faint clouds adorned its atmosphere. But this ice giant has much more to show, and not just its 13 rings and 27 moons. The planet lying on its side experiences the most extreme seasons in the solar system when the sun shines directly on one of its poles. During the equinox, Uranus is just as active as Neptune with its dark spots, and inside, it hides even more mysteries than its neighbor. Yes, today I'd like to introduce you to one of the two worlds that, in my opinion, unjustly receive the least attention of all the planets in the system. In 1779, an unknown amateur astronomer, William Herschel, decided to observe all the bright stars in the sky to check if they were binary. Using a homemade telescope in his backyard, Herschel was able to see stars up to the 8th magnitude, which are about 5 times dimmer than those visible to the naked eye. After 2 years of observations, on March 13, 1781, he noticed a speck of light that seemed somewhat different compared to the stars of the 6th magnitude. 4 nights later, Herschel returned to his star and discovered that it had actually moved relative to the other stars in the background. So, whatever this object was, it was within our star system. Initially, Herschel thought he had discovered a comet and presented his finding as such to the Royal Society in London. However, other astronomers, observing his star night after night, tried to carefully study its motion and then mathematically calculate its orbit. It turned out that the orbit around the Sun was almost circular, which didn't align well with the explanation of a comet. Moreover, this object was much farther away than any other body in the solar system observed at the time. Considering such a vast distance and its brightness, the discovered object had to be much larger than Earth. Thus, William Herschel, without even realizing it, made the greatest astronomical discovery since Galileo and his moons of Jupiter. Uranus became the first new planet discovered in the millennia of observations. It's no wonder that Herschel instantly became famous. Uranus is the only planet named after a Greek god rather than a Roman one. However, the planet was initially given various names, including Hypercronius, Minerva, and, of course, Herschel, in honor of its discoverer. Herschel himself proposed naming it after the King of Great Britain, George III, though that name was not very popular, to say the least. Instead, the German astronomer Johann Bode, who detailed Uranus's orbit, gave the planet its final name. Bode argued that since Saturn was the father of Jupiter, the new large planet should be named after the father of Saturn. To this day, most of what we know about Uranus and Neptune comes from the Voyager 2 spacecraft. Unfortunately, due to the high cost of such missions and the long travel time, no other spacecraft has yet visited these undoubtedly amazing worlds on the edge of the solar system. Voyager 2, launched in 1977, took advantage of a rare planetary alignment that occurs once every 175 years, allowing it to visit 4 outer planets. The most famous image of Uranus that it gave us, in my opinion, looks epic. After all, it reveals a view of a huge planet that is 4 times the size of Earth. This world has always been an unattainable dream for astronomers, who could only speculate about what the planet's atmosphere and its moons actually looked like. When they finally found out, some called Uranus boring, as apart from a blue-green ball against the backdrop of dark space, there seemed to be nothing else there. However, this label of a boring planet didn't last long. When astronomers finally got the Hubble Space Telescope and improved ground-based telescopes, they realized that Uranus is far from dull. In fact, it is a highly dynamic world with extreme weather, bright clouds, and powerful storms that appear and disappear periodically. But let's take it step by step. Uranus is the 7th planet from the Sun and the 3rd largest behind Jupiter and Saturn. Interestingly, the diameters of such planets, which have no solid surface, are measured at the level of the atmosphere where the pressure is about 1 bar, equivalent to Earth's atmospheric pressure at sea level. This is convenient, as atmospheres can extend far into space, gradually decreasing in particle density until they finally equal the average density of the space environment. Additionally, Uranus is 20 times farther from the Sun than Earth and completes 1 full orbit around the star in 84 Earth years. From such a distance, sunlight takes over 2.5 hours to reach the planet. It is believed that in the early days of our star system, the protoplanetary disk at such a distance from the star didn't have enough material to form 2 large planets. Therefore, like Neptune, Uranus likely formed much closer to the Sun and later migrated outward, possibly assisted by Jupiter and Saturn. It's also important to distinguish Uranus and Neptune from their more massive relatives. Unlike gas giants, most of the mass of these two planets is likely concentrated in the mantle, where there is a fluid mixture of partially frozen water, ammonia, and methane, hidden beneath a thick layer of gaseous hydrogen and helium. That's why Uranus and Neptune are referred to as ice giants. Overall, the two planets are very similar, sharing not only similar internal compositions but also comparable sizes. So it's not surprising that they are often considered almost twins. However, this is not as obvious a statement as it might seem at first glance. Yes, Uranus is only 3% larger than its neighbor, but it is also less dense, making it 15% less massive than Neptune. Of course, their differing densities suggest some differences in internal composition as well. Moreover, the planets are located at very different distances from the Sun. Uranus at 19 astronomical units and Neptune at 30 astronomical units. For comparison, this is approximately the distance between Mercury and Saturn. As you can imagine, the difference in the amount of solar energy the planets receive is significant, about 2.5 times. Yet Uranus is even cooler than Neptune, which is one of its greatest mysteries. More on that a bit later. So, calling Uranus and Neptune twins isn't quite accurate, as they are, after all, somewhat different planets. However, perhaps the main difference between Uranus and Neptune, and indeed any other planet in the system, is its axial tilt. This tilt is so extreme that it seems as if the planet is lying on its side as it orbits the Sun. It likely flipped over due to a collision with another planet or several smaller bodies shortly after its formation. In 2018, a simulation suggested that the culprit could have been a young protoplanet about twice the mass of Earth. The collision could have caused Uranus to flip over while still retaining its atmosphere. In fact, the rotation axis isn't perfectly parallel to the plane of the system, meaning that one of the poles is still positioned slightly above the plane and the other slightly below, if we align based on Earth's poles. Interestingly, the International Astronomical Union defines a planet's north pole as the one located above the ecliptic plane, so this is considered to be Uranus's north pole. But from this perspective, the planet also rotates retrograde, clockwise, in the opposite direction of most planets. Of course, such a radical axial tilt must create unique seasonal changes in the solar system and significantly influence the weather. In summer, the sun shines directly on one of the poles, leaving the other half of the planet to endure a long, dark winter. As Uranus moves around the sun, different parts of the planet gradually receive sunlight, but due to the long orbital period, Uranus's poles may not see the sun for up to 42 years. During Voyager's visit in 1986, it was the height of summer in the southern hemisphere, so the northern part of Uranus was effectively hidden from view. Astronomers had to wait several decades to finally observe and study it. When the sun began to illuminate more of the equator, astronomers saw clouds moving parallel to it. This indicated that despite the significant axial tilt, atmospheric circulation on Uranus occurs similarly to that on Jupiter and Saturn. On Voyager's first images, astronomers spotted only about 10 faint cloud structures, leading them to conclude that overall Uranus was very calm. However, in the late 1990s and early 2000s, images from the Hubble and ground-based observatories revealed that the planet seemed to have awakened. A large number of clouds appeared in the southern hemisphere, and some of them had persisted since Voyager's time. Meanwhile, in the northern hemisphere, which was gradually coming into view, the clouds behaved differently, appearing, quickly disappearing, and then reappearing again. In 2006, Hubble even detected a large dark spot in the northern hemisphere, a somewhat smaller counterpart to Neptune's dark spots. These are essentially giant storms caused by anticyclones, and it was quite unexpected to see something similar in Uranus's atmosphere. Until 2006, Uranus was considered much less active than its neighbor. Perhaps the planet awakens as it approaches its equinox, and during this time, it indeed closely resembles Neptune. However, in 2014, 7 years after the equinox, Uranus was even more active, as evidenced by bright storms captured in images from the Keck 2 telescope at the Hawaiian Observatory. Methane clouds that appeared during these storms were so bright that they were visible even to amateur astronomers. Nevertheless, the most interesting features of Uranus's atmosphere are the brighter areas at the poles, which resemble polar caps. These are believed to be dense layers of methane clouds that astronomers call polar hoods. It was expected that something similar would form at the North Pole. However, at the start of the 21st century, when sunlight finally reached the North Pole, no traces of a northern polar hood were observed. This made Uranus appear asymmetrical, bright in the south and dark in the north. However, this turned out to be a seasonal feature of the planet. After Uranus passed its equinox in 2007, the southern hood disappeared and a northern one appeared in its place, albeit slightly less bright. On these stunning images from the Hubble Space Telescope, you can see how the planet changes over 3 seasons. The northern hood can also be seen in a photo from the James Webb Telescope. In general, astronomers still don't fully understand how climate changes occur in Uranus's atmosphere, as they need to observe how Uranus evolves over an entire year. But in fact, they've only seen part of it. The word atmosphere for a planet that has no surface refers to the part of its outer shell that our instruments are still able to study. This is approximately 300 kilometers below the pressure level of Earth's atmosphere. As mentioned at the beginning, this atmosphere consists mainly of molecular hydrogen and helium, with only a small fraction of methane and other compounds. Despite the low concentration of methane, just a little over 2%, this compound dominates the planet's appearance. Methane has the property of absorbing red sunlight and scattering blue light back to our eyes. That's why Uranus appears blue-green to us. But what does this gaseous blanket hide? That's the real question. Well, until you plunge a probe directly into the planet, you won't know for sure what it conceals. However, nothing stops scientists from modeling the planet's internal composition based on its mass, diameter, rotation speed, gravitational pull, and so on. From this data, it is possible to calculate the density of the material, which in turn suggests what the planet is made of. It's also possible to model how the substance inside is distributed. In fact, models can be very effective if you take into account as many parameters as possible, such as how the planet's magnetic field behaves, in what part of the system this world formed, or whether there was a lot of ice present. Additionally, certain chemical compounds' properties can be tested directly on Earth under laboratory conditions at different temperatures and pressures. So, as of today, it is known that Uranus is the second least dense planet in the solar system, second only to Saturn. However, this doesn't mean it is made of lighter elements than gas giants. On the contrary, Uranus has a higher proportion of elements heavier than hydrogen and helium compared to, for example, Jupiter. But Jupiter, due to its immense gravitational force, compresses itself more strongly than Uranus does, which is why it is denser. Most models of Uranus's internal composition suggest that the planet likely has a core rich in rocky materials and metals, above which lies a mantle composed of a liquid mixture of water ice, ammonia, and methane. All of this is covered by an atmosphere of hydrogen and helium. Usually, the models differ mainly in the concentration of all these substances. There may be more rock and less ice, or vice versa. However, astronomers are almost certain that the icy mantle is the largest and most massive part of the planet. It accounts for between 9 and 13 Earth masses, while the core and atmosphere together have masses no more than half of Earth's. The icy mantle is not ice in the way we understand it, as it is actually a hot and dense liquid made up of chemical elements that astronomers like to call ices. The water and ammonia inside crystallize not due to low temperatures, but because of high pressure. The temperatures, on the contrary, can reach up to 5,000 degrees Celsius. This substance likely moves, mixes, melts, and recrystallizes, but exactly how all of this occurs is not fully understood. There is a theory that the high temperatures and pressure allow methane molecules in the mantle to break down into their components. In this process, carbon atoms separated from methane under high pressure could condense into diamonds and fall deeper, like rain or hail. At the base of the mantle, there may even be an entire ocean of liquid carbon, where layers of solid diamond could float freely. Yes, it sounds somewhat fantastic, but this idea has been tested in laboratories, where powerful lasers have shown that diamond rain could indeed be a real phenomenon. One of the strangest features of Uranus, which is related to its internal composition, is its magnetosphere. We are used to planetary magnetic fields wrapping around them from pole to pole, as on our planet, where the geographic North Pole is very close to the magnetic pole. However, Uranus surprises us again. Its magnetic field is tilted almost 60 degrees relative to its poles. Moreover, it does not pass through the center of Uranus, but is offset by about 1/3 of the planet's radius. This unusual geometry leads to significant differences in magnetic field strength between the southern and northern poles. While studying the properties of this magnetosphere, researchers at the Georgia Institute of Technology discovered that during a single Uranian day, which, by the way, lasts about 17 hours, the planet's magnetosphere can switch on and off. That is, during the planet's rotation, the magnetic field in one orientation becomes open, allowing the solar wind to flow into the magnetosphere. But in another orientation, the field becomes closed, acting as a shield and deflecting charged particles. Although Uranus's magnetic field is strange, it is not unique, as Neptune behaves similarly. This leads scientists to conclude that the magnetospheres of ice giants are not controlled by the rotation of their cores. Instead, they are likely generated at shallow depths by the movement of fluids in electrically conductive layers. This scenario aligns with our understanding of what might lie inside the planet. Now, we've finally reached the most beautiful feature of Uranus, its system of rings and moons. Rings are actually a characteristic feature of all 4 giant planets, with Jupiter's being the faintest. The ring system of Uranus was the first to be seen by humans after Saturn's. And no, it wasn't Voyager 2 that did it. 9 years before the mission's arrival, American astronomer James Elliott and his colleagues discovered the rings from Earth. They were observing Uranus as it passed in front of a background star, temporarily blocking its light. Suddenly, the astronomers noticed that instead of dimming just once, the star dimmed 5 times in total, both before and after the planet passed in front of it. Clearly, the ring system was responsible for these additional eclipses, which were later directly observed by Voyager. Overall, this discovery is hard to overestimate because it made rings a common feature of planets, not just a peculiarity of Saturn. Today, we know about 13 rings around Uranus. Most of them are only a few kilometers wide and consist of tiny pieces of rock and ice, no larger than a meter in size. However, 2 outer rings discovered by the Hubble Space Telescope in 2005 are somewhat special. They are located so far from the planet that they are considered part of the outer ring system. In 2006, using the Keck Observatory, astronomers found that these outer rings are brightly colored. One of them is reddish, like most dust rings in the solar system, while the other is mysteriously blue. The prevailing hypothesis is that the blue color is likely related to a small moon named Mab, which orbits within the ring. Since the ring is not visible in the infrared spectrum, astronomers believe it consists of fine ice particles and may form similarly to Saturn's more famous E-ring. There, the tiny moon Enceladus shoots water vapor geysers, constantly replenishing the ring's material. Mab is even smaller than Enceladus, so it is unlikely to have such activity, but it could lose material during collisions with meteoroids. In both cases, the ice particles colored the rings blue. Where the rest of Uranus's rings came from is unknown. However, it is generally believed that they could be remnants of a former moon of Uranus, which was torn apart by tidal forces due to the ice giant's immense gravity. In total, 27 natural moons of Uranus are known. The 5 largest have radii ranging from 240 to 800 kilometers. All 5 were discovered using ground-based telescopes, and 4 of them, Titania, Oberon, Umbriel, and Ariel, were found before the 20th century. Miranda was discovered in 1948 thanks to the efforts of Gerard Kuiper. Yes, the same person for whom the Kuiper Belt is named. Interestingly, Uranus, in terms of the number of known moons, is second only to Jupiter and Saturn. However, the combined mass of all these moons is much smaller than Neptune's. In fact, Uranus has the least massive satellite system among all the gas giants. With densities ranging from 1.2 to 1.7 grams per cubic centimeter, the proportion of water ice in these celestial bodies should be roughly equal to the proportion of rock. Only Miranda is thought to contain more ice than rock. The spectral analysis of their surfaces also indicates water ice, with a grayish tint suggesting contamination by other components, possibly carbon. Voyager, which gifted us these stunning images, only saw the southern hemispheres of the moons, which were illuminated by the sun. Nevertheless, we were able to observe some fascinating surface details of these worlds. For instance, Oberon and Umbriel appear densely covered with huge craters, 50 to 100 kilometers in diameter. In this context, they resemble the oldest surfaces of celestial bodies in the solar system. Conversely, Titania and Ariel have very few large impact basins but are scattered with many smaller craters. It is believed that the large impact basins could be remnants of early solar system evolution, more than 4 billion years ago, when numerous planetesimals frequently collided. Meanwhile, the smaller craters could be evidence of later collisions, perhaps with objects that broke off from other moons in Uranus's system. Thus, the surfaces of Titania and Ariel are likely younger than those of Oberon and Umbriel. At over 1,500 kilometers in diameter, Titania is the largest moon of Uranus and the 8th largest in the solar system. The lack of large impact craters suggests that it might have been geologically active in the past and likely experienced a major resurfacing event. By the way, due to extremely low temperatures, volcanic activity here probably involves the eruption of icy lava, which is a mixture of water and ammonia. A common feature of all the major moons of Uranus is the presence of enormous faults that adorn their surfaces. However, the most extreme ones that seem to be on Miranda's surface. It's the smallest of the 5 main moons, but probably the most intriguing due to its highly varied surface. Its canyons are about 80 kilometers wide and 15 kilometers deep. Additionally, there's a cliff over 20 kilometers high, known as Verona Rupes. If estimates of its height are correct, this is one of the largest cliffs in the solar system. On a moon with a diameter of less than 500 kilometers, such canyons appear very epic. But what is the origin of these features? It is possible that at some point, water in the moon's interior was liquid, but after the crust formed, it froze. Of course, as water freezes, it expands in volume, which could have caused the crust of this small celestial body to crack. According to scientists' calculations, Miranda could have expanded by about 6%, whereas its neighbors expanded by 1 to 2%. But Miranda is not only fascinating for its faults. In general, its surface looks like Frankenstein, as if pieced together from separate different parts. The main surface is densely cratered, but it is interrupted by 3 large regions with fewer craters, called coronae. These should not be confused with the coronae on Venus, as they are formed by different processes. Miranda's coronae are something unique in the solar system. Voyager images show only 3, but computer models suggest that there could be at least one more hidden on the far side. These structures appear as bands of ridges and valleys with minimal cratering, sharply separated from other terrain by distinct boundaries. There are various hypotheses about their formation, but according to NASA, the most likely explanation is that the coronae were created by meteorite impacts. These impacts melted the icy surface of the moon, causing a viscous mixture of ice to rise, which eventually refroze. However, the available data is still insufficient to consider any particular version of Miranda's evolution to be the definitive one. The same applies to the rest of Uranus's moons and, indeed, to the mysteries of the planet itself. By the way, one of the biggest mysteries is Uranus's strange thermal radiation. It is the coldest planet in the solar system, with the lowest recorded temperature of -221 degrees Celsius. Scientists have been puzzled for decades as to why the planet emits so little heat. Uranus is even cooler than Neptune, which is much farther from the Sun. The fact is, unlike the inner rocky planets, gas giants emit far more energy than they receive from the Sun. This excess heat remains from the time of the solar system's formation and is gradually dissipating into space. Rocky planets also emit extra heat, but due to their solid surfaces, they only emit slightly more than they receive from the Sun. For example, Earth emits just 10% more than it gets. For gas giants, Neptune emits about 2.5 times more energy than it receives. However, this figure for Uranus is much lower, even less than Earth's. Uranus loses only 6 to 8% more energy than it receives from the Sun. The problem is that none of the models of the planet's internal structure can explain this reduced heat emission. A possible explanation could be Uranus's collision with a smaller body which knocked it over. This collision may have stripped the planet of much of its original heat, leaving it with little to emit now. Another explanation might be that there is a layer inside the planet, between the middle and outer mantle, acting as a barrier to the outward transfer of heat. Again, astronomers don't have enough information to confirm or refute any of these hypotheses. Uranus and Neptune are the least studied planets in our system. This is surprising because the most common type of exoplanet that astronomers find is worlds with masses between Neptune and Earth. So, our galaxy seems filled with ice giants, and yet, despite having them in our solar system, we know almost nothing about them. Even more frustrating is the fact that there is no fully fledged mission currently being prepared to study these planets. There are several proposed concepts to explore Uranus, but no fully funded missions at the moment, at least at the time of this video. We've already sent several orbital missions to Jupiter and are now even targeting specific orbital missions to its moons, which is great, but no one has even started building a spacecraft for Uranus. By the way, the author of this video understands that it's easier to get to Jupiter, making such missions cheaper, and spacecraft don't have to travel more than 10 years to reach their goal. But even Mercury, which is arguably the most difficult planet to reach in the entire system, has had its own orbital spacecraft, and a new one is already on the way. So it's strange that two planets in our system are so overlooked that only one spacecraft has flown past them. There is some good news though. It seems that the scientific community is now seriously aiming to convince NASA to make a Uranus mission its flagship project for the next 10 years. NASA usually plans its future scientific missions based on the so-called Decadal Survey of Planetary Science. This is great, but the problem is that there isn't much time left to create a spacecraft, choose a rocket, and launch. The best launch window will be between 2030 and 2034, when Jupiter's position will be favorable. However, in May 2023, news came out that due to a shortage of plutonium, NASA would not be able to launch the mission before the second half of the 2030s, risking an extension of the flight time from 13 to about 15 years. Of course, there's an option to use more powerful rockets, like the Space Launch System, to send the spacecraft directly without using Jupiter's gravity for an assist. However, that raises the question of how the spacecraft would slow down to avoid missing its destination, and more importantly, a single launch of such a rocket costs at least $2 billion. Even if we disregard Jupiter's position, the problem of tight deadlines remains because Uranus is approaching its equinox. The sun will fully illuminate the planet and its moon system, providing the best opportunity to explore the world in all its glory. It would be unfortunate if a potential spacecraft arrived at Uranus only to find part of the planet and its moons shrouded in darkness again. In any case, even under the most optimistic scenario, it must be admitted that for the next 20 years, we are unlikely to see new close-up images of Uranus and Neptune. All observations during this time will rely solely on ground-based and space telescopes. There is some positive news in this, as you can see what adaptive optics and ground-based telescopes are capable of. In these images from Keck, Uranus looks as if it were photographed by a nearby spacecraft. The next generation of telescopes promises to be even more powerful, and by the time a mission to Uranus arrives, we will likely have a new space telescope that surpasses the capabilities of James Webb. So these distant worlds will certainly not be forgotten, but it seems their greatest mysteries will remain unresolved for quite some time.